All right, we've finally introduced the derivative. We know derivative is a rate of change. We know derivative is a slope. And now we're going to start talking about the derivative in a few different applications before in the next section, 2.5, we really talk about computing derivatives. So we got some introductory examples here. 2.5 will compute a lot of derivatives. And then the rest of chapter 2 will talk about all the other awesome things we can do with derivatives and do them at the same time. So we'll start with just talking about what does a derivative look like in different contexts that we're going to look at in this class. So just in general, the mathematical thought for a derivative is it's written f prime, usually. That's the derivative of f. It's just the rate of change of the function f. It's the slope of this function. Okay, f prime of x is essentially the slope function of our original function. And just like slope, slope is rise over run. Right? That's how we find the slope of lines. It's rise over run. So the units of f prime will be the units of the rise over the units of the run. Right? This is the units of the output f over the units of the input x. So if we have some function f of x that shows the number of people in a city in a given year, well, f of 2020 shows how many people there are in that city in 2020. F prime of 2020 means something different. F prime is the rate of change. That means in the year 2020, I'll write this out over here, right? In the year 2020, oh dear, the rate of change of population is 1,000. So that tells you how the population is growing by 1,000 people per year. So f prime talks about slope. F prime has to do with rates of change. So when I have this claim that f prime is 1,000, that means 1,000 is how f is changing. And again, it's positive, so that's why it's growing. And notice, the units of f are people. F shows the number of people. The units of x is time. So what were our units of our answer? People over time. People divided by time, people per year. Okay? And that's in general a mathematical explanation for how this looks. And then we'll talk about a couple other applications and a couple other ways that these things can pop up. So number 2, graphically, remember that f prime is the slope of the function, and it also can be thought of as the slope of a tangent line. Okay, f prime is the slope of the line that's tangent to our original function at any point. So if I tell you that f prime of x, the slope of our original function, at any point is just going to be 2 times whatever x coordinate that is. The question is, what is the slope of the line tangent to the graph at this point? Well, the slope of the line tangent to the graph, that's f prime. So what is f prime of 3? That's our slope. Well, let's calculate it. We know f prime is 2 times x. And again, where did that come from? We talk about that in the next section. So if we plug in 3, we get that our slope, again, f prime tells us the slope, we get that our slope is 6. That is the slope of the tangent line right here. Visually, we can see that, okay? We have our parabola. This is our original function, this red parabola. And here's our tangent line at that point, this blue graph. What's the slope of that line? The slope of that line is 6. All right, so that's graphically what a derivative can represent. We talked a little bit about the physical applications. We won't focus on this too much more in this class, but just to kind of go over it quickly, if we have a position function, then its derivative is the velocity, right? Because how position is changing over time, that's speed, that's velocity. Okay? And then we can take it one step further. We can actually take it a lot of steps further, but we're only going to take it one step further and say that the derivative, the rate of change of velocity, can be written f double prime, and that's acceleration. How your velocity is changing is your acceleration. But yeah, we're not really doing that much. This is bonus right here. Bonus info. You don't need to know this for this class, really. And then again, to kind of put this in perspective, suppose that f is the height of an object in feet after x seconds. And we know that f prime, which again, if f is some kind of position, f prime is going to be velocity. F prime, the velocity at any second x is negative 32 times x. How fast is the object moving after 2 seconds? Well, we just have to find what is f prime of 2, because f prime is the velocity if f is the position. So this tells us the velocity at any time. Plug in 2, and we'll get negative 64. Now, you probably just know from experience that if you have feet in seconds, your velocity will be in feet per second. But remember, if you have any derivative, the units of that derivative are going to be the units of the function divided by the units of x. What are the units of our function? F is the height in feet divided by the units of x. What is x? X is in seconds. So that's another way to see that this velocity is 64 feet per second, and it's negative, which usually corresponds to down, although it doesn't always have to mean down, but usually we have negative be down. The last application of derivatives that we're really going to talk about, and that's more of what this section is focused on, is the business applications. Marginal cost, marginal revenue, marginal profit, more topics. We're getting back into demand and supply and all of that stuff. Not going to talk about that now because we got future examples to talk about that, future videos to talk about that. And just remember, kind of as one major summary for this video, derivatives can look different in various applications. We're going to look at 4. We've talked about 3 of them. We'll talk about the business one later. But they're all rates of change. They're all just slopes. Okay, anytime you see a derivative, it just talks about how the original function is changing. Velocity is just how position is changing. Right? We got the slope of a tangent line. That's how the function is changing. We got f prime shows the rate of change of f. So if f is the population, f prime is how the population is changing. Derivatives just tell us how things are changing. And that's the big takeaway. That's the big summary here. We got some business applications in the next one. So wait, I need a good sign off. How about adios? I haven't used Spanish yet. Bye-bye.